So good evening, everyone. We already shared in the first talk, like 2 talks before, about some of the technical skills we need and the IT skills we need. And today we're going to tackle one idea or a challenge which I've met people ask me. There will be like, I want to learn software. Now, which one do I start with? And for this, I have to put a disclaimer again, and the disclaimer will be my background, because this is mostly from my own personal experience, not necessarily from other people's personal experience. My background is, I was, of course, an undergraduate in that period, 03 to 07. During that time, the only statistical package I learned, there were two. There was the SPSS and another one called S+. One of the main developers for S+ is probably the person who started R. I think there is some relationship like with that. So during that time, I learned SPSS and I learned S+, and I've never used S+ ever since. And then I got an attachment at KEMRI, Kisumu. KEMRI is Kenya Medical Research Institute. They have an office in Kisumu. I was based at the hospital called Russia. That is Jaramogi Odinga Hospital Research, Teaching and Referral Hospital, UTRH. And when I was there, we were dealing with health data, and at that time they were using a software called Statistical Analysis System, or SAS. So out of my work, like the moment we just joined there for attachment, we started on learning SAS. And all of our work was writing codes that will help to clean data using SAS. And during that period, I got interested in learning R. There was some free online courses, and I started learning R, like I shared in the previous video. From there, I volunteered in an NGO called Partners in Reproductive Health, which is in Kisumu. And during that period, we used Excel a lot more. And for some surveys that we did, we used SPSS for the analysis. And then I got a job in 2008 at Coptic Hope Center for Infectious Diseases, which is based in Maseno. They have also like they have another office in Nairobi. And in my whole work was, I used to write scripts to clean data, or rather to flag and clean data, and I was using SPSS. Now, SPSS, when I learned it in my bachelor's, I never learned how to write the scripts. So all these I had to learn by myself. And of course, it was not very hard. During my master's, I was introduced to a different software called GenStat. During that period, like, I wrote some small codes using GenStat to simulate data, and also did all my analysis in GenStat. GenStat had been a common software among agricultural researchers. The way SAS was common among health researchers, GenStat was common among agricultural researchers. And then from there, I joined Maseno as an employee, and of course, I've been using Excel, R, Stata I've used as an employee, but not in Maseno, mostly just doing other things out there. And Python, albeit to a very minimal extent, and Access, but Access is not really a statistical analysis software. I wouldn't put it like that, but I just wanted to mention that that is another data holding software that I learned. And so that means in between my career moves and my academics, I had to teach myself Stata. There was another software called EpiInfo. It still exists, but I rarely use it. And of course, I had to teach myself a lot more of Access. So back to our question for the day. Of all these softwares, which is the best one to start with? I will exclude Excel because it's automatic that everybody should know Excel because it merges well with almost every other statistical software. And Excel is very flexible. It doesn't, it's as if it allows every rule. And anybody who is a newbie can start with Excel from scratch to do all the trials they want to do. Okay. So, which one would I suggest people to start with? Excuse me. I will have to be honest here. One of the criterions I've used when thinking on which one to start is how well a newcomer can be able to see the data visually. I know in the university we teach a bit of R, and a good number of people struggle because they don't have that visual aspect of, they can't visualize how the data looks like. And for this reason, I still think I got a very great deal by starting with SPSS, and I would even recommend for people to start with SPSS. Its popularity out here, it's a lot more with people who are in social sciences. But people in data science, I think they use very little, if any, SPSS. Why would I say that? Like I say, it starts to have some very good visualizations. Not visualization, but I mean, it really makes somebody to be able to understand the data. They can look at the data and they can see what we call the data matrix, the rows and the columns very well. They can switch between views. And most importantly, the reason I really like it is before people enter data, there is a process of creating that data entry system. And that one helps anybody to understand the idea of types of variables. And I really like that about SPSS. We use R, and in most cases, we just import the data and we continue working with it without necessarily, and figure out during the procedure, which kind of variable should this be. But in SPSS, you need to specify if you want to have good data. Let me give you a quick glimpse of SPSS. So it has two views. I hope you can see the screen. You have what we call the data view and the variable view. This is what I meant when I say the data. So the data, everybody can see the columns which represent the variables, and they can see the rows which represent a case or an individual. You can switch in between the views. Let me show you. You can switch, sorry, not that. You can switch in between the views. So you can see here, when you're looking at numbers, those are the codes that people used. Like for females, the code was 2. For males, it was 1. So people, if they are categorical, you can be able to see what are the codes that were used. And how are you able to see this? Because when you go to the variable view, before you enter the data, you have to specify. I honestly don't know how to zoom for SPSS. Let me see, view. Oh, I can change fonts to 16. Okay, so I hope you can see it better. Now, here, this is a variable called marital. When you come to the variable view, this is the variable. Okay. When you come to the data view, you see it is a column, and these are the entries. But under the variable view, When I click in this column called values, it shows what each value, each category, how it has been coded. I can see when somebody is single has been coded as 1, in a steady relationship has been coded as 2, living with a partner as 3, all the way to widowed, which has been coded as 8. And then what is interesting is there is another measure. This is something you also learn in descriptive measures of scale. But if something is categorical, you have to decide whether it is ordinal or it is nominal. And, I think when you are designing this so you can enter data, it's a proper learning process for somebody to really understand the data. There is just, and of course, for somebody to work with Excel, it has menus. You can see here there is a menu for creating new variables, that is data transform, menus for analysis, menus for graphs. So it makes it easy for a person who's getting started with the software. You basically need very minimal coding skills. Now, one thing I should probably do, let me say I want to do an analysis. I want to do just some frequencies for sex, and I just say, okay. So it will generate the values in what we call an output window. But what is interesting is if you can see where there is this dotted line. Let me use some annotation here. What happens there is the command that has been run is provided there. Like here we have the command called frequencies, which has been run. The command called frequencies. And all these are now outputs concerning that command called frequencies. So if somebody is completely ignorant about how to do some coding in Excel, I believe this, not in Excel, but in SPSS, this is a nice place to start from. You can be able to copy this and put it in your own syntax file and even be able to do some reproducible analysis with it. So for that reason, I will definitely vote SPSS to be the first one. Many people out here that I know who are not in social sciences don't like it, but I will still vote it as the first one. Of course, it has some disadvantages, which is it's commercial. So for many people, they won't afford it. So that's a problem. And of course, the other thing is its visualizations, rather its figures are nowhere near as good as figures from Stata, from R and other software. And one other limitation is I've never seen SPSS analyze map data, spatial data. So after SPSS, if not SPSS, I will go for Stata. Stata, let me give you a visualization of Stata. Oh, I should probably give credit to where I got the data. I downloaded that SPSS data from this website. I just Googled. I'll probably link this in the when I upload this video online. I got this from this data. And the starter file, I got it from not this one, but from this website. I think I downloaded airline data. So Stata is like an in-between Excel and programming languages. I feel that now what is interesting about this is I will not run any command for now, but what I really like about it is you're able to see the variable. So SPSS gives you the variable in a data matrix. For Stata, you get to see all the variables that you have. When you click on excuse me, when you click on a variable, At the bottom here, it gives you information about that variable. What is the name of the variable? If it has a label, the type, and any format that is there. So if there are any categories, you'll be able to see them from there. This is important because every time you want to do an analysis, you need to understand the type of variable you're dealing with. Now, for Stata, again, it has the menu. So if you want to work with the data, you can do some, well, when you're dealing with data, you can organize the data, you can do different types of graphs, and you can conduct analysis, okay? Let's do probably a summary, okay? Yeah, summary statistics. When we do the summary statistics, you get the data here. Because you can see we have just summarized, okay? And you have a history on your left. Now, this history, just like we've done in the other one with the SPSS, people can copy this and save it in what we call a do file. Do file is just simply like like in R, the text file where you're doing the coding. So you can save it again and make it reproducible. So I can go for Stata as a second time, but I know Stata has this big advantage over even SPSS. It can work with very big data sets. I've had a case where I had a big data set and I couldn't open it in Excel. I couldn't open it in SPSS. At that time, I couldn't open it in R. And so we had to use Stata. So Stata didn't have to open the entire data set, but it was flexible enough to allow me to select several variables. Even R could not allow me to select some of the variables because it was just very big. It wanted to read, at least to understand the data set. But Stata doesn't have to read the entire data set. It allows one to record the variables and use them and select the ones you want. So it's not a surprise that many people nowadays, particularly people in demography, they will be using Stata for most of the analysis. Of course, one limitation is that it's commercial, and I've never seen it being used for map data or spatial data, okay? But of course, like you've seen, it has the menu, which makes it easy, and that menu you can move it to. You can easily move it to a do file, which is just a code. Of course, there is the SAS or GenStat. One of the biggest limitations I have about them is that they're commercial and they're very specific to areas. Like for SAS, you get that in most cases, in our context, you will get people who are in the health area are the ones who are using SAS, or people in pharmaceutical who are using SAS. But they have a nice rider or software called JMP. I think it's pronounced JUMP. It's one of the best I've ever seen. It's very interactive. But again, they are commercial, but I believe there are student versions. So even for GenStat, there are student versions. Almost all the software from number 1, 2, and 3, there are student versions which you can use to learn, and they have some trial data sets. So I would say probably if you've done the other two, then you can go to SAS. One of the biggest suggestions I have is that I don't see it being used so much in Kenya. It's probably used in the big pharma companies, even the ones that are in Kenya. But I don't know where else it's really being used a lot more. Like even in Cambridge, I think they're going towards R and Python. So that's my challenge with it. So I will not be putting this one as number one. Even for GenStat, it's been limited mostly to people who are doing agriculture in our context. But it's like a nice learning software, if I might say. Okay. Oh, but I need to mention something here. SAS, the first time I ever saw a statistical analysis software generate reports in HTML, I saw them in SAS. Nowadays, R can do that, Python can do that, but I actually saw it first in SAS, and that was then in 2007. So once you've done all that, then probably R and Python are the best because now you have a big background on what's a data, how the data looks like. The limitation with R and Python is, people see just the codes. And if you look at the environment, you just see you have this new data and these are the variables that you have. Nowadays, they have improved it a bit. You can be able to see the type of variables and an illustration of how they are. But when doing the analysis, like 90% of the analysis, you just have to know what you want to do. And so you have to write the code to do that. Like if it's the mean, you want to take the mean of something. Okay. So that is the biggest limitation I have with R, which is and Python, which is they are mostly coding. However, they have so many strengths. One is they can read in many types of data sets. I believe also SPSS and SAS can read in a lot of data sets. But R and Python can read in also map data, spatial data, and do a lot of analysis for spatial data. And they can also be used for analyzing text data, which I don't think is very good with SPSS and with Stata. I don't know about SAS. It's been a while since I've used it. And of course, for all of them, you will notice I keep talking about getting the codes. Once you have the codes, that means you can do reproducible work. And when you can write the codes and you want to redo the work again, you can basically generate the report in a span of like a minute. And this makes the work easy, as opposed to if you're always using the menu, because if you use the menu and you don't save the code, if you lose that report, it means you have to redo all the analysis and it's not easy, okay? And of course, these two are nowadays not just producing HTML data files, reports, but even interactive analysis. Like I think you've heard of a R Shiny app, and I think also Python does that, where you can be able to allow somebody to input something or select a category, and the analysis is done. You've already conducted the analysis, but they can be able to interact with the result output. And I think that is a very cool thing. Of course, the con is that over 90% of the time you're doing coding. Now, with that limitation, then we have to consider what about RInstat. Now, RInstat, I like it. I don't have any negative thing about it because, of course, it's been done by Maseno University students. Former Maseno University students are the ones who have been used to majorly develop RInstat. So it's something like you're proud of. But one big thing I like about it, it has a climatic menu, which I've never seen in any other software. It specializes for analyzing climate data in a very nice way. In a way that you can be able to do a nice report for somebody with regard to climate data, including all the climate elements, but mostly rainfall, temperature. And I think it does a very good job at that. It works with R in the background, but it has a menu. So it makes it a bit easy for somebody who's learning because now you have a menu where you can click and get an analysis done, and then you can store the codes. So because it's our own, I cannot say any negative things about it. Yeah. Now the question is, should you learn it after R? I can't tell that, but I just know you can learn it at any part, and it will really help you, introduce you to R. I think the only limitation is probably the coding. When you want to copy the code, it should not just be the simple, straightforward codes. So the limitation when you run, like if I can show you here in SPSS, when you run using the menu, the codes appear a little bit complicated. So you have to understand the code. As opposed to if you type the codes yourself, then you can make them to be very simple compared to when you run it and you copy the codes. There are a lot more software people can learn. There is the idea of business intelligence. Now, with that, I know people use W, Power BI, and those are mostly, I find them to be having like an Excel base. I've never learned them, but the issue is most people who do business intelligence, they want to see a dashboard, and that is something you can even do in Excel. I'm not saying I know they have a lot more functionalities than Excel that can focus on that. But also I know Excel is a big software that we've never really explored it to the fullness. So I think that's my comment. If you want to learn, I will definitely say if you are completely new, probably get an SPSS software, learn it a bit. It will help you improve. But SPSS, it will limit you. So most people who I interact with and are in research, they really work a lot with Stata and R. Okay, so I think that's my thoughts. I'm happy to get your comments and feedback, and also consult widely. Remember, out there, people always have opinions, like I also do. The thing is, how relevant is it in their context? So thank you, and I want to welcome any questions.
Hello. Okay, mine is first to thank you for actually letting us know basically where someone should start from. For those of us who have no idea about the statistical softwares or have not actually encountered with any. For my case, actually I don't have a question, but however, I'll say I've known the kind of sequence that I can follow maybe if I want to learn something. Even though if I can just follow through the sequence that were given us, some point in time, I think I jumped over some softwares, don't know, and I've not yet used them up to date. But by now, I think it's a good time that I can go back to them and I can have a good idea of how I can maneuver through them. Thank you so much.
Thank you. Allow me to not react, but just to add. I think this is because I have interacted with this software. Okay, I don't think you need to learn all of them. But I think probably you can either start with the SPSS or Stata, because they are being used out there. Up to now, they're still being used a lot in our context. And the best thing for students is it helps them to visualize data better. And that's why I'll be putting them at the top as opposed to R at the and put R at the bottom with Python, because it's mostly coding. And if a person is completely new to understanding data, I think they tend to find learning R is as typical. But I agree, you don't need to learn all of them. You can probably just learn SPSS and then you continue with R. You can even just learn R, depending on your skill level. Yeah, and thank you for that. Oh, By the way, also in R, you can be able to view data if you want. So you can see that data matrix, and so, or you can look at the structure from the environment or from the data itself, from the code itself. So it all depends with your skill level. And thank you so much for that comment.